Let us observe an experiment to trace the path of a ray of light passing through a rectangular glass slab. So we've taken a rectangular glass slab and we place it on a white sheet. Then almost through the center of the glass slab, we point that mark and we draw a normal. So we observe that we've drawn a normal. After that, we also draw the outline of the glass slab. This is the arrangement that will be observed. Then, with the help of a protractor, we will mark approximately 30 degrees angle from the normal and join it to the normal and the boundary of the glass slab. On this line, we are going to place two metal pins, which will be placed approximately 6 centimeters apart. We should take care that the pin should not be bent, it should be straight pin. So one pin I would join here and the other one would be placed here on the wooden board. Once the pins are fixed, just remove them and make a circle to highlight their position. Now we have to observe these two pins through the glass slab. To do so, you have to bend a little and observe the position of the pins. Wherever the images of these two pins will fall, you will have to place a third metal pin after the images of these two pins. So I have put the third metal pin here. Similarly, we will take another metal pin and we would be placing this metal pin after I observe the images of these two pins and the position of the third pin. Now what I observe through the glass slab is that all these pins are aligning in the same line. Once I place the two metal pins, I remove them and mark their position. These two positions are marked and simply now we will join these two positions with the boundary of the glass slab. Here, the line is a straight line. And if we measure the angle that is being subtended by this line, we observe that the angle is equal to approximately 30 degrees angle. Therefore, this is our angle of incidence, angle I, and this is angle of emergence, angle E. Now, if we extend the line, the normal here, and if I extend the normal here and I join the two lines, I see that I get a bent line. This is the angle of refraction that is formed. This is the angle of refraction, and if we further, you can mark it as angle R. If we further extend this line, that is the line of incidence, we get a parallel line of emergence and a parallel line of the incident ray. Now the perpendicular distance between the incident ray and the emergent ray is known as the lateral displacement. Therefore, due to the difference in the density, air and of glass, the light ray was bent, it got reflected and it emerged outside the glass slab. So there are 4 observations that we can make here. The angle of incidence, the angle of emergence and the normal, they lie in the same plane. The angle of incidence is equal to the angle of emergence, and if we extend the incident ray and we compare it with the emergent ray, both of them are parallel to each other, and the perpendicular distance is the lateral displacement which has happened due to the surface of the glass slab.